Good morning, dear ladies and gentlemen, and all the judges. Today, I'm delighted to present my research, and the topic is counter-movement jump characteristics of collegiate, elite, and sub-elite male taekwondo athletes. My name is Lin Xuanyu. The ability to generate and sustain power output of the lower limbs might be important for taekwondo athletes to support all their techniques. The counter-movement jump, CMJ, has been used to assess neuromuscular statement and lower limb power. Previous studies revealed that the CMJ was able to discriminate between levels of taekwondo athletes. However, only CMJ jump height has been recorded, so the available data on the CMJ might be insufficient to provide further insight of the muscular power characteristics of taekwondo athletes. It has been evidenced that CMJ gross measures derived from force plates are related to strength and explosiveness. Therefore, the purpose of the study is to compare CMJ gross measures performance between collegiate medalist and non-medalist male taekwondo athletes. 18 collegiate male taekwondo athletes participated in the study, and they were grouped into the elite and sub-elite group based on rankings achieved in national level competition. The elite group are those with top 3 national rankings, meanwhile the sub-elite group are those without. They all have over 6 years of taekwondo training experience and over 2 years of resistance training experience. None of the athletes were associated with any illness, injury, or surgery that restricted their lower limb function. After performing a 15-minute standardized warm-up, the subject started the CMJ test with a dowel placed on the shoulders and standing still at the beginning of each trial. They all received unified instructions to lower themselves as quickly as possible and try to reach maximum jump height. They were given a warm-up CMJ attempt, and a minimum of 2 trials was completed with subsequent trials required if performance was not consistent, and 1 minute of rest period were allocated between the trials. If the jump included arm swing or leg tuck, it would need a retest, and all the process was closely monitored by the research team. Data were recorded using a force plate at 1000 Hz sample rate, and an analog to digital converter was used for data acquisition and signal processing. Raw data were exported as text files and analyzed with a customized Excel spreadsheet. Vertical ground reaction force was measured directly by the force plate. Vertical velocity was calculated as the integral of vertical acceleration with respect to time using the trapezoidal rule, and vertical power was calculated by multiplying vertical force and velocity data at each time point. Gross measures are collected between the onset of propulsion and the instant of takeoff. Jump height was derived from flight time, and contact time is the time spent on the ground from the onset of movement to takeoff. The reactive strength index RSI modified was calculated by dividing the flight time by contact time, and the peak force, peak velocity, peak power were defined as the maximum values attained during the propulsion phase of the jump, and force and power values were expressed relative to body mass. The average of the 2 trials was taken forward for statistical analysis. Data are reported as means plus minus standard deviation. Independent sample t-test was applied to identify significant differences between groups, and statistical analysis were conducted using the SPSS. An alpha level of probability equal or under 0.05 was chosen as the criterion for significance. Intra-class correlation was used to assess reliability, and coefficients of variation was used to determine variation. The results of the study are presented in Table 2, and from left to right, there are CMJ variables, the performance of elite and sub-elite group, alpha level, the result of ICC and CV, and the ICC and CV for all the selected variables were deemed acceptable for the study. And statistical between group significances were found in jump height, RSI modified, peak power, and peak velocity. So according to the result of the study, jump height was significantly higher in the elite group, and this was in line with previous studies, showing that jump height was also higher in winning female taekwondo athletes. So it seems that higher competitive levels of taekwondo athletes are more likely to reach higher jump height. And greater peak power, peak velocity, and RSI modifier were also found in the elite group, and this could represent their better lower limb stretch and shortening cycle function. Because the nature of taekwondo performance requires bursts of sudden, fast, and powerful kicks, so that efficient SSC mechanics might facilitate their jumping and kicking actions, so that superior power, velocity, and SSC ability in the CMJ were reflected in the elite group. By way of conclusion, collegiate medalist Taekwondo athletes achieved greater CMJ jump height, peak power, peak velocity, and RSI modified than their sub-elite counterparts, and their superior CMJ performance might result from better lower assistive function that could possibly underpin their sport-specific techniques. And one of the limitations of the study is that it included a small sample of collegiate male Taekwondo athletes. So future study can therefore consider exploring CMJ characteristics in professional Taekwondo athletes to assist preparations for international level competition. This is the end of my presentation. Thank you very much.